Hi guys, sorry I'm going to be out today. I have a doctor's appointment, but I will be back on Tuesday. We are going to go over tomorrow. I will hand out the quizzes that you guys took. I did post them in the grade book. So tomorrow I will hand them back and we can go over some commonly missed questions and answer any questions you might have and talk about how you might retake it if you're interested. But today we are going to move on. If you could please pick up the notes from the counter or open the Google Doc, and the substitute can pause the recording until everybody is ready to go. These are the learning targets for today. It's really just to solve systems of equations using the elimination method. This is the last method we're going to go over. And tomorrow we'll go over how to use the elimination method when the coefficients are different, but today we're going to talk about how to use it when the coefficients are the same. So this is the definition of the elimination method, and this is what you fill in on that top box in your notes. The elimination method is a method of solving a system of equations by adding or subtracting in order to eliminate a variable. That's why it's called elimination method. So pause the recording while students fill this in and press play when you're ready to move on. These are the steps to solve systems using elimination. The words in red are the ones that you fill in. So the first step is to make sure your equations are lined up. So all the x's are on top of each other, the y's are on top of each other. Then you're going to add or subtract the equations to eliminate that common coefficient, the variable that has the common coefficient, So identify those variables that have the common coefficient. Remember, coefficients are the numbers in front of the variables. And then you're going to eliminate that variable. Then you're going to solve for the other variable, whether it's x or y. And once you figure out what x or y is, you substitute that into one of the original equations to solve for the other variable. So pause if you need to while students fill this out, and then press play when you're ready to move on. We're going to go over a few examples here. The first one, we want to look again and see which variable has a common coefficient. So if we look at the x's, this one has a 3 in front of it. This one has that 1 in front of it. So it's not the x's, but the y's actually don't have a coefficient at all. They're just y's. So it's like 1y and 1y. So the y's are the ones that we are going to target and try to eliminate. So you want to think, what can I do to get rid of the y's? Can I add them together? 1y and 1y is 2y. So we're not going to add. But if we subtract, that will get rid of the y's. So let's subtract. So what this means is we are going to subtract this entire equation from the first equation. So I'm just going to write this down over here. So this is y equals 3x plus 4. And we're going to subtract each of these terms. So we're going to subtract the y, we're going to subtract the x, and we're going to subtract the negative or the minus 2. So this is minus y, minus x, and minus 2. So when we do that, we have y minus y is 0. 3x minus x is 2x. And then 4 minus 2. Remember, minus or subtracting a negative number is the same as adding. So this is like 4 plus 2, which is 6. So voila, our y's are gone. So now we can solve this equation and figure out what x is. So let's do that by moving things away from the x. You always move what's added or subtracted first. So we have 0 minus 6. And we still have our 2x. And then you undo the multiplying by 2 by dividing. So when you do that, you have -3. So now we know what x is, and we can substitute that into either one of these equations to figure out what y is. Sometimes one of the equations looks a little easier than the other, and that's the case here. If I had to choose, I would substitute it into this equation. So y equals x minus 2. If I want to figure out what y is, I'm going to substitute in what x is. And we just found out that x is -3. So it's -3 minus 2. Which -3 minus 2 is -5. So the solution to this system of equations is x is -3 and y is -5. So pause if you need to while students fill this out in their notes, and press play when you're ready to move on. So let's go over this one. This one is very similar. You first are again finding out which variable has the same coefficient in front of it. And if we look at the x's, we see they both have a 3. So you want to think, well, what do I do? Do I add these together? No, that would be 6x. We need to subtract again. So let's subtract this whole thing from that top equation. So we have to subtract the 3x, we have to subtract the -9, and we have to subtract the 15. So what we end up with, if we want to write it down over here, minus 3x minus -9y and minus the 15. When I do that, 3x minus 3x, that cancels out, and then -10y minus -9. That's just like adding, remember? Subtracting a negative number is the same as adding. So that would be -1y, or -y. And 14 minus 15 is -1 as well. So now y is almost by itself, but not quite. In order to get rid of this multiplying by -1, I'm going to divide by -1. And that gives me 1. Y equals 1. So now we can substitute that into either one of these equations and solve for x. Now in this case, neither looks that much easier than the other, so I am just going to pick the top one. This 3x minus 10y equals 14. If y equals 1, I'm going to substitute that in for y here. So I have 3x minus 10 times 1 equals 14. Well, before you start moving things around, you always simplify. 10 times 1, that's just 10. So this is 3x minus 10 equals 14. And then when I start solving this for x, I'm going to add 10 to undo subtracting 10. 14 plus 10 is 24. And then we can divide by 3 to undo the multiplying by 3. So y is 1, x is 8. That's the solution to the system of equations. So please pause this recording while students write down this example and press play when you're ready to move on. All right, here's another example. This one is slightly different. In this one, if you're looking for the one that has the same coefficient in front of the variable, you see this has a 4 and a -4, so it's not exactly the same. This is one of those cases where instead of subtracting one equation from the other, we can just add them. Like 4x minus 4x, that cancels out. If I add these two equations together, then this is going to cancel out. So 4x minus 4x is 0, so that cancels out, and now I just add the rest of it together. 9 plus 7 is 16, so I have 16 y's. 5 plus 11 is 16. And now, in order to solve for y, I just need to divide by 16 to undo that multiplying. So this, very quickly, helped us see that y is 1. I think this elimination method is a lot faster and easier than the substitution, if you're lucky enough to have the coefficients the same like this, especially. So now that we have figured out what y is, we can look at our equations and see if one is easier than the other to substitute that into and figure out what x is. I'm just going to use the first one because they both look kind of the same as far as difficulty. And I'm going to put 1 in for y. So instead of 9 times y, it's 9 times 1. So everything else stays the same. And now before I start moving things around, you want to simplify. So this is 4x, but instead of 9 times 1, I'm just going to say 9. And now I'm going to solve this. Sorry, I don't need that line. So at this point, it's a two-step equation. You want to move things away from the variable. So let's subtract the 9. And 5 minus 9 is negative 4. And the very last step, undo the multiplying by dividing. Okay? So hopefully you guys are able to get a handle of this. We're just eliminating one of the variables and then solving for one and then substituting it in to solve for the other. So pause while the students write down this example and press play when you're ready to move on. I'm actually going to skip over this one. This is pretty similar to the one we just went over, where again, you just have to add them together. Negative 3y plus 3y. If we add them together, that's going to cancel it out. So you guys can try this one on your own if you'd like. I'm going to move on to the last two, which are special cases I want you to be clear about. So here. So if we look at this one, again, we have the ones that have the same coefficient in front of the variable, and I have 3x and 3x. If I subtract 3x from 3x, then that would make the x's go away. So let's try that. Let's subtract 3x, subtract the 4y, and subtract the 13, because we want to subtract this entire thing. So you have to put that minus sign in front of each term in that equation. So we have 3x minus 4y equals negative 10. We're going to subtract the 3x, we're going to subtract the negative 4y, and we're going to subtract the negative 13. So 3x minus 3x is 0. That cancels out. This negative 4y minus negative, remember subtracting a negative is the same as adding. So this is just like adding. And when we have a negative and we're adding the same thing, that also cancels out. So on the left side, we have 0. And on the right side, we have negative 10, and we have minus negative 13, which again, minus negative means that we're adding. So negative 10 plus 13 is 3. So this is one of those cases, remember, the variables went away. We end up with a statement like this, 0 equals 3, which is not true. No. So this is one of those cases where there is no solution. When they give us something silly like this that's not true, no solution. So think about that. If it's no solution, what do these look like when we graph them? They are parallel lines. You don't have any solutions in common. So this can happen with the elimination method too. There's one other example here. This one, we have to first line up our x's and y's. So we need to move things around a bit. So I'm going to make mine look similar to this one with the x's first and then the y's. So I need to move my x over to the other side. So if I have negative y equals 2x plus 10, and I want to move my x over to the left side, I'm going to subtract it because I don't want it to be over here anymore. So I have to subtract it over here as well. So this would be, if I want to put the x's first, I'm going to say negative 2x, and then my y, negative y, equals 10. So I have now changed my equation. So if I look at these two together, 2x plus y equals negative 10, and negative 2x minus y equals 10. You think about this, these both 2x minus 2x. If I add these two equations together, they're going to cancel out. So 2x minus 2x is 0. Y minus y is 0. So I have 0 on the left side, and negative 10 plus 10 is also 0. So if the variables go away, just like when we did substitution, if the variables go away and you end up with something that is a true statement, then that means that there are infinite number of solutions. Or you can say the infinity symbol. If we were to graph these two equations, we would see that they are the exact same equation. They share all the same solutions. All right? So that's all I have as far as examples. As far as practice for you guys, I want you guys to practice this. You have choices, okay? You can choose if you want to do the Khan Academy, which I think is better. If it were me, if I were a student, I would do the Khan Academy, the systems of equations with elimination, because I can see instantly if I got the question right or wrong, rather than going through and doing some problems and not knowing if they're right or wrong yet until you turn them into me. But if you prefer, I know some of you guys prefer worksheets, so if you prefer to do this worksheet, I have one that the substitute can pass out. There are two sides. One side has questions for lesson 6-3, and one has questions for lesson 6-4, which is for Tuesday. So if you are wanting to do the worksheet, please get that from the substitute. If you are doing the systems of equations, the Khan Academy here, please write down, I want to see your work. Now that I've showed you how to solve these using the graphing calculator, I don't want you to use the graphing calculator to do this Khan Academy. Show me your work and I'll give you credit for it if you get at least a 75%, okay? If you use the graphing calculator, this is going to take you 2 seconds to do. So please show me that you can go through this process and use this one instead. All right, so I'll see you Tuesday. Can answer questions for you then, and I hope it goes well. I'm going to post this recording in the classroom as well in case you'd like to see it.